Good afternoon, everyone. Today my voice is clear, or is it like yesterday? Okay, all right. So, again, good afternoon, everyone, and we will today discuss about pig. We just left pig till the introduction yesterday. Today we will go deep into the various details. And so, here, if you, my slide should be visible. All right. So yesterday we briefly went into this hello world kind of. It's not really hello world. It's like a full-fledged script. And because I believe that people who are from SQL background, if you show them the real code, they will be able to figure it out very quickly. So here I'll just go through this script very quickly. So this first line loads the data, second line prints the data onto the screen, and third line shows you the data type of this data set. And afterwards, you group the data by a particular column, and afterwards you iterate over the groups that got generated. And once you after iterating, you compute the average and then save the average onto a file. All right, so here it is. All right, okay. So that's, I mean, whenever you are learning a programming language, you generally go back and forth between suddenly seeing a code and then theory, then code in the same way. So this is how a typical pig script will look like. All right, now, so there are, before we go on to explain each and every aspect, let's first define what are the various data types in pig. So this is quite common. Anybody having any basic programming language knowledge would be knowing about these data types. First one is an integer, second is long, third is float, and fourth is double. Double is bigger than the float and the precision is higher. Okay, so in case of double, the 8 bytes are required. Okay, then there's something called char array. Char array is the string which we deal in most of the programming language. String is equivalent of the char array, and then there is a byte array. Byte array is specifically designed for the binary data. Okay, so by default, if you don't describe your data types, pig assumes the data to be in byte array and then later on it casts. All right, now second one is the complex data types. Complex data type is composed of either a complex or the basic. Okay, or a combination of two. For example, first one is map. Map is essentially a key and the value pairs. Okay, just like hash table or dictionary or hash map, all of those are basically synonym to map. Map is key and the value pair, a collection of key and the value pair. Here the key is a character array, a string, while the value is another complex type, or the value could be a scalar, meaning the value can be another map having the same structure, or the value can be int, long, and double, char array, byte array, or any of that. All right. All right. So the second data type at pig is tuple. Tuple is essentially a fixed length ordered collection. Okay. Tuple is equivalent to a row in the database table, right? So a tuple can be two columns, three columns, multiple columns, or tuple can have different types of data in it. But here, in case of pig, unlike in databases, the data can be generally in the primitive form, each column. But here, each value of the tuple can be a complex data type. It can be a map, it can be further another set of tuple, and so on. All right. So tuple is like an array. Tuple always looks like an array where elements are indexed from left to right, 0, 1, 2, 3, 4, 5, 6, 7, and so on. Okay. I think in case of pig, it starts with $0. Yeah. So you can refer each of the values inside a tuple. Like here, you see a Bob, and Bob is basically a word which, when you refer to it, you can either refer by a name of the tuple you have given, or you can refer to it with a positional fields such as $1, $2, $3. All right. Now, so you might be wondering what would be the difference between a map and a tuple. Okay. So in a map is like a hash table, and tuple is like a row of the database table. All right. A tuple can have the name of the columns or may not have the name of the columns, right? So basically, in case of a tuple is more like an array, okay, where the index can be a number or the name, and so on. All right. Now there is something interesting which is called bag. Bag is like set of rows or a data set. Okay. Bag is an unordered collection of tuples. Bag is an unordered collection of tuple. The way a table is a collection of rows, similarly a bag is a collection of tuples. All right. The important property of bag is that in case some of the tuples do not fit into the memory, it spills over those tuples onto the disk. All right? You don't have to worry about the data growing big when we deal with bag. Sounds good to you? Two tuples can have different fields, yes. Two tuples lying in a bag can have different set of fields. All right? Unlike in case of a database, two tuples or two rows in a table can will always have those columns. Okay, will always have same columns. That's not true here. Okay. Now, sounds good to you? All right. Now, before we define any schema, so what is schema? Schema is a sort of restriction imposed by database onto the data you put in. For example, in when you put data in a database in the form of table, you generally have to first convert your data, flatten your data such that a table is basically composed of multiple rows and each row has multiple columns. And these columns have data types. Okay, these columns have data types. All the values in a column have to have the same data types. Similarly, all the rows are supposed to have the same set of columns. So this sort of imposition, these sort of constraints are termed as schemas. That this is the schema of the data which we are putting in. Okay. In case of pig, in case of pig, there is no imposition of schema. You can have your data with column names, without column names. And when you are loading the data, you can load it as a full line and later on split that into values. And all the values by default will be considered as bytes. And later on, you can convert those values into integer or string or whatever you deemed right. So, Pig is essentially not very particular about schemas. Pig tries to guess Pig tries to guess what is the data type based on the operation you try to do. So, so there are so either you tell Pig that this is the way, these are the columns, and the columns have got these data types. For example, either while loading this data, you can say load it as a set of these fields: exchange, symbol, date, and dividend. Exchange is a character array, symbol is a string, and date is also a string, and dividend is a number. All right. So we can tell upfront, either we can mention in the load statement that these are my columns, okay, and these are the data types. Or we can also simply say load this. Okay, in that case it will think initially, it will try to uh, it will by default consider the input to be separated by tab. Okay, so it will create four fields out of it, give them will not give them any name, but you can refer them by, instead of giving them name like exchange, symbol, or date, it will not give them a name, but you can refer them by $1, $2, $3, right? And all of them will be byte array by default. Okay, and it will try to make very intelligent guesses when you try to use the data. It will try to cast the data into that data type and then remember that data type, right? Now, why is it so? Because the kind of data which Pig or any of the big data tool is supposed to handle can be structured or semi-structured, or can be completely unstructured. All right, that is why these kind of data types are required. For example, when you try to process the data from something like a pig, something like Apache logs, the data is heavily unstructured. And when you load that data, either you keep on defining the data type of each and every field, or you can just say that these are my field, this is my data. We will do the analysis later. Okay. Now, all right. So the way we define the data types of complex data type, we generally define it this way. The way here we said for simple data types, very straightforward. We say float straight away. And in case our dividend had been of type map, had it been a key value pair, we would say dividend colon map and then array sign, just like this. Okay, this says that the field A which we are trying to load is in this form. Or we can also further go ahead and even tell what is the type of the value in my map. Remember that the key of the map is always a string, while the value can be declared by the user who is loading the data. Okay. Now, when it tries to load the data, it would try to think of it this way. Okay. A hash B, C hash D. All right. And then it will parse it. While the fields are separated by tab, the key value pairs are separated by a hash, and the tuples fields in a tuple are separated by comma, and bags are separated by curly bracket, is inside the curly bracket and is in the brackets. I'll show you this data. All right. Now, for time being, have a look at the way we declare the way we declare in while defining a table. Create table with these column, this as this data type. Similarly, we are defining the fields over here. All right. Now let me just turn off my phone. All right. So you define the data type in this manner, and as you can see in this definition, you can see you can either say that, hey, my particular field is a tuple, and we don't even tell how many fields are there in the tuple. Or we can go ahead, we can say there are two fields in my tuple. Okay. And we can further go ahead and say my tuples field defining the data type of each of the field in the tuple. All right. So that is the thing which basically gives you a lot of control over semi-structured or unstructured data. All right. Similarly, while defining a bag, you can define that the bag is going to contain the tuple of these types. Remember, bag is supposed to have tuples. All right. And when somebody asked me that can uh, can two tuples in the bag be different, the answer is yes, although we define the data type here. But in case a field is missing, a particular field is missing, pig does not complain much about that. Okay, it just assumes it to be null. All right. So here we say that the bag contains the tuple and tuple contains these many fields. All right. Also, similar to Java, we can cast one data type to another by affixing a data type in front of it. All right. Now, so let's start with a simple load statement. Okay. So let me just start from the beginning. So I'll just logged in. Okay, let me go back. I did SSH student at hadoop1.nobigdata.com. In case Hadoop 1 there are many users, you can log into Hadoop 2. There's no issue at all. All right. Now I started pig command without any argument. So it will start the it will give me the grunt. Basically a prompt where from I will be firing my pig queries. So when I do ls, I'm actually doing ls on my hdfs. So even if you are not using pig for your usual work, you can actually use pig for interacting with hdfs. So let me go to a folder called data. So when I did cd data, I actually did a cd on the hdfs. Now when I say ls, now I'm inside the data folder. All right, that is why only the files from data folder are coming. Now when I say dividends divs equal load this data, okay, now you can see this. Now if I dump divs, all right, so it is going to and you can see that whenever you fire up any query, it basically converts that query into maps and reduces. And this conversion of maps and reduces is exactly similar to our problems which we discussed, how we converted our join, how we did this in those five problems. The conversion of these queries into MapReduce is similar to that. All right. So you can see that it loaded the data, and gave you the prompt. All right. Now, before I go further, I want to see, I want to see what is there in that data. Okay. Do a cat in that data. So you can see that the fields are tab separated. All right. The fields are tab separated, and these are the values. And what did we do? We just said load our data. That's all. And when we said so it loads the data, and if we want to see what is there in the data, we said dump. And if you want to see further that what is the kind of data set it has, so it says the schema for divs is unknown. All right. If we had defined, we have said uh, I mean, we have said load the data into divs using, and these are the columns you could have got, you would get a set of columns defining here. All right. Now you can also say explain will tell you what does this whole thing contains. So it basically says it's like your query plan. Whenever there's an SQL query, what goes inside it is described by query plan. Similarly, you have explain, and you say explain and data set. So that will give you what will exactly go on when we try to dump the data from this data set. All right. So also notice two things here. When we said div equal to load nyse underscore dividends, it did not fire anything. It basically noted down that there is some file like nyse underscore dividend which need to be loaded into divs, but it doesn't do it. It's quite lazy. It will do it when it is needed. Meaning, when you try to dump divs, then it will go to NYSE dividends and start reading from there and then printing onto the screen. All right. So this is very important to remember that load NYSE dividend is not going to start reading the data from that file. Instead, it will sit back and wait for you to you print the data or try to store this data somewhere else. You will see this. Okay. So it's like saying, it's like creating a view over a table. Okay, it's like creating a view over table. Whenever you do a select query or something, then only it is going to go to that table. Okay. Now, now tab is a usual separator. In case you want to load something which is comma separated, you put NYSE dividends using pig storage comma. All right. Had your data been comma separated, you would have used that. For example, say we have got all right, let me try to say. So okay, actually, let me just see if we have something. So we have this file users.csv. Okay. So when we say this, and also remember, right now we are in a live mode, which means when we say cat or ls, it's actually talking to HDFS. Had you been running it in pig minus x local, you would have been getting the results from the local file system. All right. Now here, as you can see that your data is in the form of comma separated. If you want to load something like this, you generally say, you generally say load users, okay, using pig storage, and then you can say dump. So while when we said cat, it simply interacted with HDFS and dumped the whole data onto a screen. When we said dump divs, it's going to create MR job, and then each MR job is going to work on the cluster and give you the results. Sounds good? Now you can see that it has formed the tuple out of this, which is comma separated, right? Fair enough? Fair enough? Now, similarly, if you have multiple files and you don't know the pattern, you want to load all of those files into a single data set, you can use wildcard characters. All right? You can use wildcard characters. So if you have lot of nysc underscore div and then 1, 2, 3, 4, 5, 6, 7, 8, and whatever it is there, load all of that into divs, into a single data set, concatenating one by one. All right. Now, the next one is load nysc underscore dividend using HBase storage. This is something interesting. So, while loading data into pig, it's not necessarily that your data need to be available in the local file system. You can need to be available in HDFS. You can also read the data from a database such as HBase. And there are plugins, there are drivers which are available for loading the data from relational database also. All right. So although the query is little bit different from here, I will, because it requires the full name of HBase storage here. Okay. So yeah, the question is, or when we are loading this A star, so A1, A2, A3, do they all need to be in the same format? So the answer is uh, they need not to be in the same format. So in case there are two different files and containing one containing three columns, other containing four, that is fairly acceptable. The only problem will arise when you try to operate upon data, and if you try to access the column number 4, which is not there in the first file but which is there in the second file, in those cases the data you will get will be null. All right. So the problem is similar to what you have in any strongly typed programming language and non-strongly typed programming language. In case of strongly typed programming language, most of the data sanity check happen at the time when you're loading the data. But in non-strong programming type programming languages, the data check happens when you actually try to assign, cast, or try to do something. All right. Now, if you want to load the file and you want to specify the columns, you can specify this way. So let's load it this way. All right. And when we say now describe divs, it will show you this. All right. And we can also say dump divs, and now you will have a query being fired onto the Hadoop cluster, and you will get the results. Sounds good to you? Now let's go ahead. Now these are few nice things to know. One is explain, as I showed you. Other is describe. And explain shows you the execution of what will happen in the background when you dump the data set. While describe shows you what is the current data format of this data set. And there are syntax highlighting tools, and in case you are you start using pig heavily, you can use these highlighting tools for Vim, TextMate, Emacs, Eclipse. So you can see that it has loaded it this way. Okay, sounds good. Now, so this was load. Now, if you want to store this data into somewhere, what do? You use dump or store. Okay, store stores the data to a file or other storage. All right. So for example, we want to say store my data set called processed into a file called processed using pig storage, and save my data comma separated. If you do not specify, if you try to say, for example, store, so we have divs, right? Now if we say store divs into divs file, okay, and that's all we need to write into. All right. Now what will this do is it will just take whatever was in the divs and put it in, put it into this file. All right. Now by default, the data which goes out is in the form of tab separated. If you want to make it comma separated, you can say using pig storage comma. All right. Now then there is something called dump, which we have been anyway using, prints the data onto the screen. It is quite useful while debugging the script during the writing time, or it can also be used to save the data into local file system. How? You run your script using pig myscript.a, and in this script, if you have a dump statement, everything will come onto the screen, and then you can redirect. So pig myscript and then put a redirection and save it data somewhere. So that will, using dump, you are able to save the data onto the file, local file. But again, not really for production use. It is generally for printing and debugging. All right. So now there is something called for each. For each essentially goes record by record, top to bottom, iterating over the data. And when you say for each and a record, you need to say generates. For generate also. Generate is something which generates the next set of columns. All right. So you can say, think of it, select star from this table. For each looks like select star from my table. All right. Just that for it is reverse. It says from this data table, select these columns. All right. So that is the syntax. So okay. So using storage, logical storage or physical storage. So we are storing onto HDFS. Okay. Internally, whether it divides it onto blocks or divides it elsewhere, we don't care. We are just as if we are writing to a file. All right. Writing to a file. Now, your probably actually that logical storage we talked about is mostly related to when we are talking directly to MapReduce. Okay, yeah. So you can think of it as HDFS is physical storage. We are telling HDFS, here is a file, store it. Here is our data, which is going to be two tuples are going to be new line separated, while fields in the tuple are going to be tab separated by default or comma separated as we specify in the pig storage. Now we tell that this is how I want to store my data, and we start giving the data um, to HDFS, and it starts storing the bytes which we are giving it to. All right. So now, in case of when we say for each, we are essentially saying iterate over this data set and only pick these columns. All right. So sounds good to you? This is not average. We call it values. No, we can do this. So we have stored into div file. Let's do ls. So there should be a file called divs file here, and if we say divs file, it should be essentially copy of the. Okay. So I've deleted that file. It's essentially a copy of NYSE dividends. If we had put a comma, it could be comma separated values. All right. Now inside for each, there are further more details to be discussed. So after you have loaded price like this, now there is another table, another file called NYSE. Let's see what is there in NYSE daily first of all. Okay. So it contains so many columns. NYSE daily contains so many columns as you can see. Okay. Now the next thing you can do is load it into prices. We loaded that table into prices. Now when we want to, either we can do this, okay, meaning we want to find out the difference between close and open. All right, we want to find out the difference between close and open. So we can do this. We can say dump. All right. Or we can, if we have not given the names of the column, we can actually say this. Okay. So 1 2 3 4 5 6, actually it starts with 0. So positional parameters. Okay. So all right. All right. So here. All right. So yeah. So we can also say this way. So as you can see that it has calculated the differences between the gain. All right. And similarly, we can also say close minus open. That's what it computed. And we have these values now. Similarly, we can do this also. And also, if we just want to keep only 4 columns out of all the data. And remember, if you are loading like this, you are really not loading the data. So it's okay to load everything once and then pick up columns from this in the next statement and so on. Okay. So it's not, you don't, need to start optimizing from the beginning. You can load all the data and then select only few columns and then operate on that. Okay. And when we say generate dot open, we are saying all the columns including open and before. Okay. So if you want to select exchange symbol date and open, we can say dot open. If you want to only select open low, open high, low and close, these 4 columns out of this data set, we can say open dot close. Okay. So it's like select star, select a dot star, select b dot star. Instead of saying that, you can say this way. All right. Now this approach has got some problems. If we can, it does not let you select columns by their names but their positions. All right. If you want to select only volume and aadj underscore close, you can say volume dot dot. All right. So this is the way you can select multiple columns in case of pig. Sounds good. Now, now one question for you. Now we learnt about this. We learnt about this that we will when to use map, when to use have reducer. So will it have any reducer generated code? Meaning when we say for each prices generate close minus open, do we require anything, any aggregation to be done? Or we just require the data to be read from file and dumped onto the disk? Yes? Yes, mapper is not required. So will this have any reducer generated code? Okay. When you run any pig command, it shows you that how many reducers are being generated for some work. As you can see here, so let me show you. When we say dump gain, here if you see it'll show you. Now, if you notice that it in our gain problem, it actually removed these columns. In this statement, it removed everything other than close and open. So 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. Okay. So it pruned all other columns which were not required. And also here it will show you what goes on inside it. You need to have a look at what is going inside it here, right? Okay. So here if you look at this, so there are no combiner, no reducer, but there is a mapper. Okay, there is a mapper. Okay, so mapper basically picks up 5 and 9, 5 and 9 column, and in case of a gain, it's just one column which is there. So that's another issue. But right now you can see that there is a mapper while the reducer and combiner is not there. All right, and also if you pick up the job itself, it will show you. If you pick up the job, it must have given you a job. Here is the URL to track the job. All right, it will show you that essentially there was no. Okay, so there was no reduce at all. You can see that. So there was no reduce at all. Good, good. Because, and in very, very simple words, when there is no aggregation, there is no reducer. Now, moving on. Yes, almost for every query mapper has to there, because mapper means we are loading data or iterating over filtering the data. That all happens at the mapper side. All right, sounds good to you. Now let's talk about some more things here. Now there is another file in the same folder. It should be available to you guys also. Okay. So in this one, so do you also open up your a terminal and start working together, or will you do it in your own time? Now there is this complex type. Okay. Here each row contains values which are tab separated. So first one is essentially a character array, and second one is, let me just copy it from here. And all right, let me copy a little complex one. Okay, and let me increase the font so that you are able to, so that the data doesn't intimidate you much. Now first is this tuple, and show wrap show invisibles. So whenever you see the arrow here, this is a tab. So first is this field, second is this field, third is this field, and fourth is a tuple. Third one is a map containing only one value right now. Had it been this particular row, this particular data, there could have been multiple values, right? You can see that. So this data is essentially the scores of baseball team players. The first one is the name of the player. Second one, which team he belongs to. What are the character traits of this particular player, and when did he bat? Okay, his batting history. Okay, so his name is, for example, this is Carlos. His team is Chicago Cubs, and this is essentially his character traits. He is a starting pitcher, and also a pitcher. And this is his history. It says that this history is in the form of key value pair. This is essentially a map, not tuple. I'm sorry. Tuple is generally represented with the round brackets. Here it's a square bracket, so it's essentially a key value pair. Here the key is this and the value is this. Okay. So in this case, if you want to load the data, if you want to compute the average, so if you want to compute the only we want to pick up, we just want to print the batting average of each user, like this portion of the whole thing. Instead of all of this, all we want is the name of the player and their batting average. So what will we do? What will we do? Okay. What Okay. Well, here we loaded everything. We said first is a character array, second is a character array, third is a bag of values, third is a bag of values. This is the bag of values. Okay. And fourth is a hash map. All right. Now we can operate upon it. And basically, I'll just add one more thing into it. We can say name. All right. Now, All right. Okay. This is, let me first load it. So it's loaded, and there we go. We say dump avg, and what will we get? The font is visible, right, to all of you? You can see that we were able to find the, so Carlos has got how much average? 0.236. Carlos has got 0.236. Can see that? And also, whenever the value was not available, it is printed as blank, right? So it doesn't complain, it doesn't give you an error. Okay. And in the last case, the Greg somebody, oh, that one also has a value. All right. Now, in case you want to just access one portion of the data, for example, out of a tuple, if we have a map, sorry, if we have a bag containing lot of tuples, and out of these tuples there will be lot of fields. In each tuple there will be lot of fields. Now what do we want is we want to trim such that each tuple should contain only few fields. That we can define it like this. Okay. All right. If tuple had 10 fields, we could just picked up x comma $1, which means x and y, right? So this way we can cherry pick values from the whole complex structure and then generate the data. Similarly, so actually when I was talking about this. Okay, I was talking about this. So in case you want to pick up only one values of all whole of the bag, you can do that using this. Okay. Similarly, if you have if you instead of if we had say here z int, then we could this would generate only two columns output in of the bag. Okay. Now this you can iterate over and test, and and to get the feel of the complex data structure, you should basically create a file of this format, load it into the data, and then put it into HDFS, and then load it, and then try to see how does the complex structure behaves. Because why I'm suggesting you to load it, because complex structure is something which we have never dealt with while operating on relational databases, because the complex structure was broken down during the period of database design as well as ETL. All right. But in case of pig, the whole process, because we don't define the structure upfront, we we do operations on data, and if we require, we flatten it, we remove things. So it is very important for DBA, for developer, for testing, to understand the complex data type. So go through a couple of examples, try to load it, try to see how you can manipulate the data. And if you get stuck somewhere, just drop me an email, and then we can discuss it. All right. Now, all right. So also in the generate, we can do the usual multiplication. And also we can do things like square root or something. So for example, in this, what exactly we are doing here is we are we are multiplying the values by 100, we are multiplying dividends by 100, and we are also giving it a name, and we are multiplying. We can actually do a lot of things. We can divide by something, and we can also apply functions, and all the detailed function which you can apply here, you can have a look at it. All mathematical functions, sine, cos, tan, everything is available here. And say for example, you want to do a square root. Okay, you want to do a square root. So you can simply say sqrt of this one. That's all. That's all it needs. All right. Okay. So it's mostly the for each statement is mostly like your select statement. Now the next statement, which is quite obvious to all of you, is filter. Filter is the where clause. Okay. The where clause you have in SQL, you have filter over here. Okay. So the load and for each is essentially a select clause broken into two. While filter is the where clause, we say that filter this data type by a condition. A condition can be a value and an operator. Value, operator, and operand. Say for example, you want to find out the the stock prices of all the symbols which start with CM. Okay, so now we can simply say dump this. So okay, who is not aware of regular expressions? Who is not aware of regular expressions? Okay, so basically regular expressions are a form of pattern matching. Here we are saying CM followed by anything and any number of times. So effectively this means it will match with CM and CM followed by any character. Okay. So here it gave us only the results of symbols where that symbol with the name was matching with this pattern. Okay. Therefore you see CM, CME, CMP, CMU, CMK, CMI, CMO, CMA, CMC, right? So we said filter this data, this whole data which we loaded in the first step, by with, when the symbol matches this description. Similarly, if we want to say reverse the condition, we can say not symbol matches this, right? And if we put plus over here, can somebody tell me what will it match with? Or if I put, so right now I got these results. Okay, I got these results. You can see it has CMO, CMA, CMC, CMK, CMU, CMP, CM, CME. Now, if I say dot plus, what will be the results? What is it that, what difference will it make instead of dot star? Anybody? Yes. So cm dot star matches with cm, cm, but if you dot say dot plus will not, if you say dot plus, it will not match cm. Okay, so cm dot plus will not match cm. There should be at least one character. Yeah, you are right, Sasikant, thank you. All right, so okay, looks like I need to, let me have a look at if I shared, if I've shared the regular expression course with you guys. And if it is not shared, I'll just send you an email with the recorded session. Here is the recorded, all recorded. Okay, okay, okay. Looks like I haven't done. Okay, okay. I need to find it in my regular. Yeah, here it is. So I'll just share this URL with all of you. All right. So okay, and I will share the URL with you. Okay, good, good. So basically, I prepared a simple regular expression session of around 1 hour, 1.5 hours, which should give you a fairly confident overview of regular expressions. So regular expressions are fairly important thing. If you are a developer, you are into ETL, you are a tester or DBA, or even if you are into business analytics, regular expression is something you should learn. Okay, it is a very very helpful productivity tool which will help you in many ways. Now, so basically it is for pattern matching, and pattern matching is needed every time you do any data journey. And regular expression has become omnipresent. Earlier, before the regular expression, if you remember the DOS commands, we had star dot star and A star, B star, and so on. Those were wildcard characters. That thing evolved into regular expressions. All right. So the session which I have shared with you is basically for learning how to use regular expression, not the automata theory. Perfect. Good. So in a filter, whenever you say filter your result set by conditions, if there are multiple conditions, you can put and or in between them, or you can combine them together by putting the brackets. Okay? By putting the brackets. So most of the operators you can also have a look at here. So because why I have not gone into the details, because most of them are exactly like your SQL. So you don't need to do a lot of a new learning. It will be the same thing. Okay, it'll be the same thing, just that a little bit of syntax is different. Okay. And let me also show you a couple of things. Yeah, boolean operators, for example, you have and or. So filter a by this or not this or this. So these are all fairly common operators, exactly the way these operators were there in SQL. All right. So basically, filter lets you filter the data by a certain condition. It's equivalent of where clause. Okay. Now again, if we have this, will there be any reducer generated? If you had to do this by hand, if you have to find all only the lines, do you need to do you not need to do this? Yes. Reducer is not required in this case. Thank you, Karthik. Now, so just like SQL, you also have order by. You load the data and then say order my data set by A, comma B, comma C, comma D. So it will order first by symbol. In this query, if you can see, first it will order by symbol, then symbol ascending order. If you don't define in which order, whether ascending or descending, it will do it in the ascending. Also, if it has figured out the data type, if it has figured out the data type, it will order by that kind of a data type. Okay. Remember, in case it figures out it doesn't figure out the data type is numeric, it will consider that as a number, and therefore mm, 2 will come before 12. No, 2 will come after 12. Yeah, right. Sounds good. So that's the order by syntax. Similarly, you have distinct. In the distinct, so order by and distinct. Okay. So this is order by, similar to SQL, where we order the data, and then we have distinct. Distinct basically finds the unique tuples out of the input data. Unique set of tuples. Okay. So you generate your column and then you say distinct this. In when we say distinct, all the values of the tuple are compared against others, and then the result is derived. Okay. So for example, if we want to find out what are the various distinct symbol in our input, I'll ask that question. Don't worry. All right. So basically what it did was we loaded the NYSE dividend. We picked only one column over here. We could also pick up two columns and then do a distinct over it. Okay. And then we'll get a distinct set of symbols. So we got these many symbols out of it. All right. These many symbols. Sounds good to you? Now, will it generate any reducer code? Unique symbols equals to distinct symbols. So Tuntun's answer is yes. Okay. Karthik says yes. Okay. How do you compute the distinct values out of a set of value? You pick up a value, if and then check against all the values you already have at hand. If it is not there in that hand, you just put it in your hand. Then you pick up any other value from the whole pile. Then check it whether you have it at hand or not. If it is there, you just uh, drop it. Otherwise, you keep on doing it. So which means that you will end up looking up so many times. For n values, the total number of steps will be n square on an average. So for first value, you have to look up in 0 elements. Then for second value, you have to look up in 2 elements, and so on. So you will keep on doing it over and over. So so it's a complex process. What is the best way of finding distinct? If I ask you that given an array of element, find the distinct element, how what exactly will you do without using any libraries? Anyone? Given an array of values, if you have to find distinct, will you use two for loops or will you use something else? What will you use? What if you don't have a set? Anyway, we have actually discussed this problem in when we were discussing about word count. We have actually discussed it that we will sort all of the elements, okay, whether in memory or on the disk, or divide the data into multiple parts and do all the sorting. And once you have sorted, then we will just pick up on only the elements. We'll just if these records are sorted, so you start reading from the top and you keep on skipping till that value is being repeated, and then you pick up the next one. Why? Because duplicate values will come together in the sorted data, right? So the sorting is the best approach if you have humongous data as opposed to the hash table. All right. Now, so the answer is yes, you require the, it will generate the reducer code. Pig will generate the reducer code. If you don't believe me, let's have a look at what is this guy doing. So I think I'm going into the previous ones. Total input paths, deserialization, setting parallelism to 1. Here, if you see, it says clearly that reduce phase detected. You can see estimating number of reducers. Okay, input size estimator is this, and therefore it says setting parallelism to 1, which means there is going to be only one reducer. Okay, bytes per reducer is 3 plus 3 plus 3, 1 GB. 1 GB is in 10 to the power 9 zeros, and then maximum number of reducer is 999, and total input size, file size is this much. So this is our input size. It will be divided by this, and then reducers will be computed. So here the reducers is 1. That's what it is. Okay. So that output which pig prints is there, you can actually make that output silent if you don't want it by using a flag. Okay, so effectively there is a need of a reducer in this case. All right, now moving on. So here there is something which is missing, and that is our important aspect. Okay, let me. All right. Before moving on to join, I would like to also discuss something else. Okay. So that something else is group by. Okay. So you once you have loaded your data in this form. Okay. If you have loaded this data in this form. Okay. You load your data. All right. And then we say for, for symbol this we gen. Okay. We say here group divs by symbol. Okay, so basically when you say group by is a two-phase process in case of pig. Okay, and group by is a two-phase process. First you group by, then you iterate over the group. Now the newly generated data set becomes like this. Each row becomes a contains two things. One is key and then actual tuple. Actual tuple. Okay. Okay. This is what it becomes. And afterwards, when we go over it, we say actual array of all the actual tuples with the same key. Okay. This is what it becomes. So when you want to generate in this case, what and remember we have got each row, each tuple has got these many columns, and so effectively for each of the symbol we'll have array of tuples. Now when we say for each, we can say we want to group by symbol and we want to sum up the dividends. Okay, so for each value we want to do this sum up. Okay. So let's see what happens. We said group dividends by symbol, and after that we said iterate over the grouped data and find out. Okay, generate group. Group is the name given to the group is the name given to the column here. Group is the name given to the column. Okay, which will be your symbol value, and here everything will be as usual. Okay, so just a second, let me. Okay, this will say grouped, this not that. Okay, divs. All right. All right, now let me go over grped. So note that the function name was case sensitive, while syntax of load can be load, filter, or group by. The syntax group by can be in capital, lowers, doesn't matter. But when you are making a call to the functions, that need to be case sensitive. Okay, because all of these functions are sort of dynamic, sort of coming from the library, and the way you define in library is pretty strict. Okay. All right, so you can see that. So it did not do what we wanted to do. Oh, what did we print? Oh, we print grouped. Okay, okay. So basically here, if you can see, the grouped was this group by symbol. So what did it generate? It generated tuples containing the key, and then the bag of all the tuples which have the same key. You can see that all of these rows or tuples are equivalent of all of they have same symbol, cato, 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 cato. Okay, so for basically what did it do? It basically grouped all these rows together which have the same key, and that's what is contained in the group. Now if we say dump symbols is something. Where did we store? Yeah, symbols. So we said dump symbols, and let's see what happens. Symbols is this one, basically where we said sum of divs and group. Okay, is it clear or did I confuse you? Feel free to ask. Okay, I think this will give you a better. Here you can look at this. So instead of average, right now we are doing summation. Okay, to understand what is there inside grouped data, you should do a group dump grouped once and then see. All right, so you can see that the values have been summed up, and these are the values. Okay, you can do round and all of that which is available as part of the library. If you don't like this kind of format, you can do a round. All right, so is everybody with me now? There is something called join is probably we all know. Join is probably we all know as part of our SQL understandings. Join is essentially a cross multiplications of two data sets. Okay, that was as part of our SQL understanding. When we joined two tables, we never needed earlier to specify a filter. Specifying a filter was optional, but in case of pig you need to specify a filter criteria on the basis on which you need to join two tables. Okay, join means when we say join this table and this table based on this column, means find out all the rows from one table which contain the value as this one. Okay, so based on a value, say you have a1, a2, and there is another table which is a20 and a30, right? What do you want to generate is, let me just put it b. Okay, what do you want to generate is that for a1 and 20, b it is 2 and 30. This is what you want to generate. All right, meaning for each of basically you want to bring together those row values which have got the same value of the key. Okay, so which shows that we would require a lot of analysis. If we had to do this without a join, it could have been very, very difficult. Ideally, what will we do is we'll combine these two data sets and then do a group by, and then we'll do the for each. Okay, instead of doing all that juggling and magic or writing MapReduce for it, you can use join. Okay, so let's say that we have got column 1. This is the name of this one is column 1, and this is value 1, and this is column 2. Okay, column 2, and this is value 2. All right. Now, when we want to generate this kind of data, where we want to give it some column name and we want to get value 1 and value 2. Okay, what do you do? So, if we give them a name called dataset 1 and dataset 2, these are our dataset. This is one dataset, this is another, and we want to do a join D1 and D2. And which column do we want to pick up from the D1? We want to pick up column 1, and we want to pick up column 2. Sounds good? We basically are saying find out, bring the the data from the two tables together which belongs to the same column, so same column value, right? Yes, those are there. Just have a little patience. And good, good. So I'm going a little slow here. And here you can also join based on two column values. If there is a customer ID and you have two tables, and say customer is defined by, or say there are an employee is defined by department and employee ID, right? So you can join the two tables containing employee together based on two columns also. All right, that is composite key. Now, unlike our unlike our relational databases, we cannot have the self join. Okay, you will have to have load statement twice to have the self join. All right, to have the self join you have to load the same file twice, and then you join them as if you are joining two different data sets. Okay, so there are few differences. Before I go ahead, I will like to pinpoint join the differences of from our RDBMS. Okay, first, the join should always have at least a column, right? If you remember the joins in relational databases, we could say select star from A comma B. Okay, and we never needed to specifying a constraint on which we need to join these two tables was optional. Okay, here it's not optional, you need to specify at least one column. Okay, now second is join cannot have conditions. Okay, what does it mean? We cannot say join join a comma b on a dot value greater than b dot value. We cannot have this. This is not, this is wrong. Okay, okay, all right. So the join cannot have conditions as per pig. All right, now, so these are the major differences you will notice when you deal with pigs joins. All right, so join cannot have conditions. And can somebody tell me, out of all of you, can somebody tell me why are these two constraints? Anybody? Or let me put it this way: how is a join converted into our MapReduce? Okay, so join is converted into MapReduce. If you think about the dynamics, how would you convert a condition into MapReduce? You should get your answer. And similarly, join should at least have a column is answered by the same phenomena of MapReduce. Okay, so are these two conditions acceptable? Do you get it? Why do we why are these two kind of problems we have in join in pig? So Karthik's question is, what if two columns are not the keys? Meaning, all right. So there is a difference of join from the RDBMS, and we need to look at it. All right. Now, yes, you are right, Nandin. You can actually write it to all. I think by default, it's organizer selected from their drop down. So yes. So because in mapper there has to be at least one key, and therefore these are the constraints. Okay. All right. Now let's take a 10 minutes break, and okay, back by 4, back by 3:49. Hi guys, I'm back. Should I start? Is everybody with me or have I put you to sleep? I think I have put you to sleep. So, okay, so starting now. All right, so now regarding joins, okay, regarding joins, the only restriction was with respect to selecting at least one key and only the key. No condition can be the criteria for joining. Okay, only the equality is something which is supported. Okay, so only the equality which is supported in case of joining. All right, why now? So furthermore, there are multiple kinds of join. The simple one is the one which we have showed you. It's a standard inner join where we are saying join A by ID. So we have got A table and B table, one Sandeep, two Ryan, and here one Giri, three Saha. So if you join by ID, only the one which has is matching the ID in both the sides will have a record in output, while the other rows like Ryan and Saha will get dropped. Okay, all right. Now next is join A by ID, left outer, and B by ID. So what is exactly happening? So this is what we call left outer join. Okay, left outer join, or straight away the left join. What does it mean by left join? That the one on the left hand side, the one on the left hand side of this keyword called left is going to be there in the output, whether the right hand side has a corresponding value or not. Okay, so the all the values from left will be there in the output, and in case that value is not found on the right hand side, you get null. For example, one, there is a corresponding value on the right hand side, therefore there is one Sandeep, one Giri, while for two Ryan, there is no such thing on the right hand side. So we have got two Ryan and then this. All right. Also remember that this keyword has to be before the comma. Basically, this keyword has to be before the comma in between A and B. Okay. And you can omit outer. Okay. Because there is only left outer. There is no such thing called left inner. All right. Therefore, you can say join A by ID left, comma B by ID, and then you can done. All right, sounds good to you. Now, next is the right outer join, exactly like the previous one, except that the values from the right come in the output. Okay, the values from the right come in the output. Although the same thing can be emulated by putting B to the left hand side and say left outer join, and then you would require one more for each phase to swap the values. Okay, to reorder the values in the input. So this is similarly right outer can be right alone. So is it clear to everybody? Is there any doubt? Okay. So joining is simple join is a value has to be there on the both sides. The column on which we are joining these two tables together should have equal value. Okay. In case a value is missing, the output doesn't come in the output. Okay. There has to be strict intersection. This is strict intersection. Okay. All the rows from A which has the corresponding value in B, only those values come in. That was join. So is that clear, Tuntun? Now, left outer means all the values from left will come in irrespective of whether there is a corresponding value on the right hand side. Okay, and what value are we talking about? The column on which we are joining these two tables. Okay, that is left. Similar is right. The values from the right hand side will go in the output, while the left hand side, even if there is no value on the left hand side corresponding, there is no id existing on the left hand side. Now there is something called full join. It's a combined of left and right. Okay, so you can deduce that the full join is essentially the left and right combined together. Okay, so it's like saying a plus b. Okay, so full join is clear. So first, all the rows which are common in between the two will come. Then the left join one, where the ID for which there is no value in the right hand side will come. And then there will be something like this. So my question to you is, if A has got, question to you is, A has got n number of rows, B has got n number of rows. Okay. So full join C is our full join on A and B. Okay. Join join A join A by ID. Let me just put it. Okay. All right. Now RO will have how many rows? If it has N or M, RO will have less than N rows. So you have three options. Option 1, less than N. 2, less than M. 3, less than N plus M. Which answer is correct? All right. Okay. Good. Good. All right. Now we have perfect. Pawan's answer is perfect. NA plus NB. NA plus NB minus N of A and B. So NA and B is equivalent to, I mean, intersection A and B is equivalent to the inner join we talked about earlier. All right. Perfect. So this is basically a union of both the sides. All right. Now, anybody, what will be the answer here? The outer join. Anyone? Okay. This is a bit of teaser, so don't get mad. It's a bit of teaser. All right. The answer is error. Okay. Answer is error. Why? Because as I said, the keyword has to be in between. Okay. Only then left or right will make sense, right? If we have the keyword in between. Uh, okay. So left or right, okay, should come before. All right. Sounds okay. Now this one quickly. Yes, you got it right this time in the first shot. Yeah, it is actually error. Why? Because you can omit outer, but you cannot omit left or right. Okay, perfect, perfect. Now there is something called limit and sample. Limit and sample. So limit is clear. We want is out of the full data set, we want to get only 10 records. Okay. Instead of printing the whole thing and waiting for the scrolling to finish, you can actually use limit. Similarly, similarly, you can also use something called sample. Sample is little unique to pick. Sample gives approximate number of records randomly selected out of the input. Okay, a sample of the whole data set, and every time sample is going to give, every time you run sample, every time you say load data and then dump, every time sample is going to give you a little different sample. Okay, say for example, when we say sample divs point 1, it gives us 10 record. Okay, now imagine this. If you have 6 records, how many records will get printed? Anybody? Sasikant says 1. Okay. So answer is either 1 or 0. Okay. If you have 6 records and you are printing 10%, so there could be 1 record or there could be 0 records. Alright. So that's because a sample is an approximate technique, and and it has to figure out, it has to have a set of randomization attached to it. Okay, sampling does not mean that our resources will decrease. The resource consumption, it is not an optimization step, it's a randomization step in which we want a random data for which we are going one step ahead. So in case you use sample, in case you use sample, you will be basically using it to test your data set against a different sample every time. Say for example, if you have got, if you have say a billion records, and you do not want to generally process all of them, but you want a fair amount of randomization, you do not want that only first 10, last 10 or middle 10 should be processed, you want to process random 10 records from the input. In those cases, you will use sample. Okay, we say sample, and then we say dataset name, and then we say this ratio. Point 0.1 means 10% of records, 1/10 of records. Point 0.2 means 20%, and so on. All right. So while limit is good, whenever you are working on a data set, whenever you're working on a problem, so the way you should work is, say you have a equals load my data, and then you have b equals group a by xyz. Okay, now the smart move here is you say something called a0, and a equals to limit a naught by 10 records. Okay, so in this you will always be working on a smaller subset. Okay, so as you are developing your program, and when you say here dump b and so on, it'll work fine. And once you are done writing your whole query, at later point of time you can just change it to a and comment out this one. Okay, so that is how you generally do, that's how you generally write a bigger kind of program and while testing it. All right. So limit is quite useful. Sample is good for statistical analysis of data. And like for example, when you download data from Twitter, Twitter itself gives you a sample of the whole data. Okay, why? Because they cannot give you the whole data, and they cannot give you only one section of the data. They have to fairly randomize it. So sample is very useful in those syntax, in those situations. All right. Now, here is a question for you. If we have loaded a data set called sum equals sample divs, there is a divs. Let's say that let me just make it bigger, little bigger. Okay. All right. Now we have, say, divs equals load divs. Okay. Now, okay. Now we have loaded the data, took a data set, I mean a sample out of it. Now we say dump sum twice. So you will get different set of record or same set of records in both the runs. Same. Okay. So answer is no. Okay. Prashant says no. Karthik says different. Sasikant says same. Okay. So on the prima facie, it looks like it will give you same records, but as we discussed earlier, any of the when you dump a data set, only then this whole processing starts. Okay, and also note that every time you dump it, the whole process of sampling as well as loading will happen again. So the whole process is going to be repeated twice. Okay, the whole process of loading file and sampling it is going to happen twice here. All right. So hope that is clear, Sasikant now. So basically, when you load a file or when you do sample, it doesn't do anything. It just makes a record saying, hey, this is what this user wanted. And when you dump it, only then the whole process gets launched. Okay. All right. Now, next syntax in the line is pig parallel. Parallel is quite a useful thing. Parallel is quite a useful thing. Why? Because the way in MapReduce, it gave us the ability to run reducers on multiple machines. We should also have a similar kind of flexibility. Okay. By default, pig tries to do some sort of magic. Pig tries to do some sort of magic, and that magic to get be configured. So when you have a lot of data, and what do you want is to do some processing, how many reducers are going to get created? That's a big question. All right, that's a big question. So instead of having it one, pig tries to do some sort of magic. So what pig does is it quickly samples the input data which you are trying to process, and based on that input data, num- number of reducers are decided. Okay. Now if you notice these few things, so based on input set of data, if your input file is there, okay, so if it is of 2 GBs, you will get two reducers. Okay. And if it has got these many GBs, okay, it will only have 999 reducers. That's the upper limit. Okay. So this input file is before the map has started. When the map started, when you started loading a file, if this file is beyond 2 GB, then pig will say that we will create. I mean, if this file is of more than 1 GB, pig will create two reducers. Okay. All right. All right. Okay. Okay. So is the voice okay now? I'm hoping that it doesn't happen like yesterday. All right. Okay, then let me try to put in furthermore. Now, so we were talking about reducers and how many reducers. By default, if your input data is less than 1 GB, there will be one reducer. Okay. Otherwise, the number of reducers will be equal to data divided by 1 GB. Okay, and plus 1. Plus 1 as in when you divide to then whatever is the, because it's an integer division. All right. So if it is 2.1, the total number of reducers are going to be 3. Now, out of this, if your total number of reducers are going beyond 999, the total number of reducers will be 999. Okay. So after this computation, if reducers are coming out to be more than 999, it doesn't go beyond that. Okay. Because it assumes that because reducer is going to run on on different machines, and it is assumed that people will not have more than 1000 machines free for running the reducer. Okay. Now there is a few of the faults here. First, pig can do only up to a certain amount of analysis. The way here is that pig is trying to figure out based on the input data, right? But if you remember our uh, character frequency analysis problem, in that problem, although our data might be beyond hundreds of GBs, okay, but the amount of work our reducer or combiner had to do was very small, because it was only having few variables. So we did not need to have so many reducers. Okay. We did not need to have so many reducers when it came about I mean, so what I'm trying to say is pig can only do the guesswork up to a certain level. You will have to take the call that do you require multiple reducers. As a thumb rule, if there is a lot of work your reducers are going to do, if your reducers do a lot of computation, it takes time, then you need to divide it, you need to distribute it. Okay, therefore pig gives you the control of tuning number of reducers. Pig provides you a keyword called parallel. So parallel effectively controls number of reducers. If you say parallel 10, you are saying have 10 reducers. If you say parallel 1, it'll have only one reducers. Okay? Parallel does not control number of mappers because mappers is controlled by how many input splits are there. In any case, so Tuntun's question is that in any case, 999 will be max reducer for any amount of size. Yes, that's correct. All right. Now, so parallelism is basic promise of pig. If you remember, pig flies, pig gives you control. So parallel keyword abides by that philosophy, and it basically controls number of reducers. Number of mappers is are not impacted because number of mappers are a function of how many input splits are there, how many machines are containing your number of containing your input split. Right, so reducers is effectively in terms of parallel keyword. So if you say parallel 10, you can say it will create 10 reducers and so on. So that is the configuration keyword you have. Okay, Prashant, is that you're looking for? Now, in case in case you may want only for one particular case, you may want the parallel, while for other one you might do not want these many reducers, right? Because your script can contain hundreds of statement, therefore parallel can be attached to each individual statement, as well as parallel can be attached to the whole script by using this kind of statement. If you do this, if you do it script wide, if you have 10 group by, all of those group by are going to have 10 10 10 each reducers. Okay, although sequentially, but this may not be required for a lot of people. That is why parallel keyword can be attached to each statement. Okay, okay, sounds good to you? If you create more number of reducers than available in your cluster, so in your cluster if you have only two machines and you have created 100 reducers, so there will be a separate 100 processes running. Okay, and separate 100 processes running, and they will create 100 different files. Okay, so if you look at it, you are essentially overloading the same two machines by using 100 reducers. So it doesn't make any sense to do it that way. All right. Okay. Anybody? Okay, so let me repeat what I just said. So you had only two machines, okay, and you said parallel 100. Or while running your map reduce job, you said 100 reducers, okay. So what will happen is it will create 100 reducers. Out of 100, it might send 50 to one, 50 to another machine. There are only two machines, remember that, in this cluster. But there'll be 100 different processes launched, and will your data will be divided into 100 portions. Keys will be divided into 100 portions, and hence the data. And the churning will happen on in these 100 different processes. Okay, sounds good, Sasikanna? Anybody else having doubts in this? Okay. Now my question to you is, how many reducers will this command produce? Anybody? Yes. Why two? No reducers, you are right. All right. Because here, because here everything will finish on the map side itself. So if you have to do the same thing, if you have to just iterate over the whole file, starting from left, top to bottom, most of it could be done. There will be no reducer side logic. Okay, there will be no reducer side logic because you are not doing any aggregation per se. And hence, does parallel command does parallel command have any impact on this? Yes, yes or no? Right. So parallel command will not have any impact on this because there are no reducers involved. It's only the mappers which are involved. Therefore, there will be zero number of reducers, and hence parallel command will not have any impact on this. Okay. Now, just opposite of what group by did. Group by brought the rows together. When we group by on a key, it brought all those rows together which has the same key. Okay. Flatten is just opposite of the group by. Flatten, what does it do is it loads a file, it goes iterate over the file, and then generates the, basically if you look at here, it will essentially generate the, one row per key. Okay, it will take a bag, it will flatten it and generate all kinds of rows. Okay, so if you have Sandeep C C++, so there will be two rows generated for Sandeep, Sandeep C, Sandeep C++. All right. And similarly is case with Arun. There will be two rows: Arun shall, Arun see, and so on. Okay. So flatten is essentially just opposite of our group by. All right. Sounds good. All right. In case, so when you are calling external functions, because in an organization there will be legacy code, there will be so many existing kind of functions which may not be in Java, which may be in Java, or which may not be this this way. So basically you can and lot of functions may not be implemented by pig. So you might want to call your Java functions from pig. If you are calling standard library function of Java, that is very straightforward. All you got to do is, all right, is this still breaking? Not clear? So sounds okay for now? Okay. Okay. So one is there are many things which could be in the real life scenario. You wanted to run pig script on some data, but before that you need to decrypt it. Or maybe before that you want to run it through your existing APIs. Or there is some service in your organization which converts a particular data into the format into another format, and that needs to be called from within pig. There could be hundred of such kind of problems, right? So for that, pig provides you the ability to call the external functions. First one is, if you want to call the Java library, standard library, then you can simply call this way. Okay. So for example, you can say that my define a function called hex. Okay. And then say invoke for a string this particular function. Okay. This particular function. So what is integer dot to hex string? If you look at it, so this function is essentially a static function. So for a static function, you can simply say define my function and invoke this function on this argument. All right. And whenever you want to do that, you can basically use a hex function the way we used sum or average. So exactly this way you can call it. Just that, try to convert it into integer before calling hex. Okay. So that's what it is. So it's a static function, you can call this. Now there is a function in an external library, okay, or internal library you want to create a class. So what you can do is you can say register this class, okay, and then you basically define a function such as this one, define convert, and Here, before defining convert, there is this class called currency converter. This acme.jar contains a currency converter which has got a constructor that takes two arguments. All right, so convert essentially, and this class will have only one function called execute. Okay, so whenever you call convert, that execute function will be called from currency converter, and you will get results. I'll show you this example. This is sort of, you are implementing, you have extended, this class is basically implementing pigs interface. Okay, one pig Java interface would be there that has to be implemented in this class. Now there would be a scenario where you want to call a Python function. Okay, so for first was standard Java library function. Second one was using a custom library you just created for the use of pig, which is using another libraries. Now now here, when you want to run your data through a Python program, what you can do is you can register that, you can call register, and then you can use your Python program, and you can give it a name. And once you have given it a name, you can call the functions available in that file like this. You can say bball.production some value. Okay, this way you can call your Python function inside the pig. All right, so the general strategy when you are doing the lot of data processing is to use pig, and whenever there is a custom development required, people develop the plugins for pig. Okay, now next one is, so just like the MapReduce streaming library, where we simply took a existing command and passed our data through that standard command, like word count, grep, sed, and unique. We passed our data through these commands. That is called, this whole mechanism of passing data through existing commands is called streaming. Okay, so whenever you have a lot of legacy code lying around, okay, and you want to inevitably pass your data through this legacy code, you can use something like this. Okay, you can say stream my data set through this particular command. Okay, now two things to note here, two things to note. First, it has got backcodes. Okay, it has got backcodes. It's not us straight away codes. These are backcodes. Why pig has chosen to use backcodes? So that in case you have to put single quote inside it, or maybe double quotes inside it, you can use double quotes. Okay, therefore they have put a backquote here. All right, it's not that they are angry people, it's just that they have thought a little bit more. Okay, so here the other thing you should note is that hidiv.pl should be available on all the machines that this is get executed. So also, if you don't give absolute path, it will try to infer this location from the uh, path variable. So therefore you should give an absolute path like this. Okay, so what will happen is, it we will stream our all the records of divs through this command, and whatever it will be become like as if all the records from s div is being given as the standard in std in to hidiv.pl, and whatever coming out from hidiv.pl, you will take it and save it in high in this another data set, and then you can continue your usual business of pig forward. You can keep on churning this data set further. Right, now this is a big problem. in case this high div.pl is not available on all the machines, and this is not, that is mostly the scenario, that is mostly the scenario, that this particular Perl command is not available on all, you might have to ship it. Either you have a central command, you can, do you know that command can remotely execute things on various nodes? So either you automate the copying of this one, or installing of high div.pl on all the machines by using things like SSH, or using systems like Puppet. Puppet is one thing which is used to control the whole data center. So either you install it by yourself, or do some way make this high.pl available on all the nodes, which is generally cumbersome. Therefore, Pig has provided you with the ability to copy this file by it, while you are executing it. Okay, so you can define your function like this. Okay, high div and backcodes, right, along with the argument. If the this command requires some arguments on the command line, you can provide them here. And then you can also say that ship this. Okay, which means before executing these big commands, it will take this Perl file and copy all around. Okay, it will copy it around on all whole cluster, and then it will execute it. And once this is done, it will automatically get deleted. Sounds good to you? So here, instead of saying hidiv.pl in the backcodes, we are saying hd. All right? Is everybody with me? Good. Okay. So there is something also called for each nested. Okay. There's something called for each nested. Basically, when you have two data sets, all right. So say for example, our problem is find count of distinct names in each city. Okay. So right now what we had just now is, in the generate we could only write one statement, but for each nested makes it possible to write multiple statement after generate. Say for example, what we require here is find the count of distinct name in each city. Okay, so this is our input, this is our output, this is what we want from this input. So Bangalore has got Sandeep and Vivek, and New York has got only John. So the count of distinct name in New York is 1 and Bangalore is 2. So anybody, any suggestions from your side? Yes. All we want to do is we want to count the distinct name in each city. Here we have two concerns is need both city and name. Okay. Key is city comma name. All right. Then right, right. So so yes, we group by city, fine, and then do a for each and count it. That's exactly what we are doing. The only thing is we have taken, so that is the reason why for each has provided you brackets in which you can write multiple statements rather than writing a single statement. So you can put curly brackets and then you can do put a lot of statements inside it. So for each group, the data which is there, like people.name, people.name is available as your separate data set, and then you can do all of those churnings. You can apply limit, you can do order by, you can do all sorts of functions inside these brackets. Okay, you can do that inside these brackets. So the people as in all the data set containing all the people for each group will be availed to you here, and then you can apply all sorts of aggregations and everything inside it. That is why it is called nested, because inside this further you can do for each. Okay, here you can again do for each, but the last statement in this, all of this should be a generate statement. Okay, the last statement out of the for each should be a generate statement. Sounds good to you? Say, all right. So that is for each nested. You should practice for each for a couple of examples, and then you will get a hang of it. Okay. Now let's see. Now this is interesting. This is interesting. You remember our join example where we were joining two tables containing million by million. Imagine one of the two tables are very small. Instead of 1 billion records, the second table contains only few records. Say, take a case of converting the country name into code. Okay, so we have got a database of citizens in which the country is represented as country name. We want to convert it into ISD code. Okay, all we want is instead of name and country name, we want is name and country code, country ISD code. Okay, as you can see that Sandeep in, instead of Sandeep in Kumar U as Gerald CN, we want is this, we want in this format, and hardly there are few hundred companies across the world. So so what do we want to do? How would you do it? If we try to join it, if we try to join it, what will happen is we will unnecessarily be doing lot of map reduces. We could actually do this, solve this problem on the map side itself instead of the reduce side. We can load the right hand side data into a hash map, as somebody has suggested in our class. That okay, so either we go for a standard join. In that standard join, this data will be having reduced phases and all of that. Or what we could do is we can load the second file into memory in a hash map, and then do the lookup of first table itself. Okay, we go one by one and keep on changing it, the country code. All right, we can create an array representing, you know, representing country as a number, and then we can convert that. It would be quite straightforward. Now the question is this is fine, this optimization is fine, but how do we tell this to pig? So pig actually gave you an inbuilt functionality of doing this. So whenever you are joining one very small table with one big table, you mark the small table as replicated, and pig will basically copy that table onto all the clusters and load it in the memory instead of doing a standard join. Okay, so that is replicated. As you can see, join this and this by country using replicated. So the cc dataset will be loaded into memory, and it will become really fast. So the objective of replicated keyword is to provide you with a extremely fast fast step. It is giving you the control of taking a call whether to load it in memory or do the standard join, do the standard map reduce. Okay, so that's the purpose of replicated. Similarly, there are many optimization steps provided by pig, because it is you who knows your data better than pig. It is you who should be thinking about how to process my data. And basically pigs gives you a lot of controls, and assumes that you will think in terms of you know solving your problem and as well as optimizing your problem. Okay, the other thing is other optimization knobs provided to you by pig is on skewed data. So what exactly is skewed data? For some keys, there are too many values, and for some keys, there are too few. Imagine you are joining two tables. For one user, there are millions of records, and for another, there are one record or two records. Okay? You can imagine a database like a population and country. So, population and city. For one particular city, there would be millions of users, and for another, there will be 200 or 100. Okay, so if you try to join such kind of skewed data, it becomes a problem at many places. Okay, it may say, for example, in the reduce phase, if you try to load, do summation or do something, it becomes a very big problem. Okay, so if there are too many values for some keys and there are too few for some, that means we are dealing with skewed data. Okay, and you should use the skewed keyword against the table you are trying to join, which has the skewed relationship. Here it's users. Okay, it's users, and therefore you can use skewed that side. Okay, now there's something called, so as if you remember, when we were discussing our map reduce phases, we talked about that merging assorted data such that the overall data remains sorted is far more easier, because the data is already sorted, right? So if you had two data sets, daily and divs, which are already sorted by symbol, and you are trying to join these two together, you can take the benefit of those two data set already sorted, right, by putting a keyword called using merge. Okay, if you are joining two data sets which are already sorted, okay, say daily is also sorted by symbol, divs is also sorted by symbol, and both of them have been resulted from certain steps from above, Therefore, it makes a lot of sense to just merge them instead of sorting. Okay. Can you explain the skewed using table? Okay. So basically, whenever you expect your data is when you are joining two tables, right? When you are joining two tables, and if you imagine what is going inside. So when you join by city, so you will create map reduce phases where city is the key, and the value is the whole row from CINFO, and similarly the value is a whole row from users, and then you join them together. What if for some keys there are so many values that they cannot be done, cannot be handled in a reduce phase? Our function within the reduce phase cannot handle all of those values. Okay, these values need to be somehow divided into multiple phases. Okay, so if you put skewed keyword there, then the strategy of doing a join over these two tables would change. Okay, instead of forming key based on the column on which we are joining, the key will be formed on on basically the key and the row ID. Okay, let me try to answer what I'm trying to say. So you have got a table which is huge. Say user 1 has got 1 million values. So table 1, user 1, 1 million values, and table 2, user 2 has got 100 values. Okay, so it has two column, user 1 value and so on. The only thing we know about is this. Okay, similarly table 2 has got a column called user 2 and there is a value. Now here there are, okay, now in this scenario when we are joining these two tables on user 1 equals user 2 or something of that sort, some of the keys will have so many values that handling them in a single reducer might become a big hassle. Okay, so pig will try to break it into multiple phases and then do a sort of a reduce. Okay, pig will try to do the reduce such that should be able to handle all these values gracefully. Okay, so that is why the skewed keyword is used. All right, so whenever you suspect that the column on which you are joining the table, for that column some of the values are going to be too high in number and some of the values are going to be too small. Okay, the column on which you are joining there are multiple keys. Key 1 is having 1 million values and key 2 is going to have 100. In those cases you should use skewed. All right, now merge is okay. Everybody clear about merge? When your data set you're joining they're already sorted and you're joining, you can make it really faster by using merge. All right, it gives a humongous benefit. All right, now so a lot of times we first join table and then group by, and this is a common phenomena. This is a common phenomena. So whenever you have to join and group by together, you can use co-group. Okay, you can use co-group. Here, let's say there are owners and then there are pets. So okay, and we want to basically join them and group them together such that for each animal all the data comes together in this form, right? So for cat you can see that there is Alice is a cat, Adam is a cat, Whiskers is a cat, Paws is a cat, and so on. Okay, not Adam, I mean Adam is the owner and having a cat. So basically we want to bring everything related to cat together by joining the two tables. So we want to bring everything related to cats together, and therefore we want to do this. Okay. So say for example your data was is lying in two tables, and you want to group your data after merging them together. Okay, after merging them together. So in those cases you would like to do co-groups. Okay, you would like to do co-groups. So is co-grouping okay with everyone? I think I should have another example of co-grouping. Okay, say you have table 1. Okay, here ticker, let's call it stock ticker, is one column and price is another. Now you have got another table. Okay, you have got another table. It is called ticker and multiplier. Okay, so let's say X is our value, price is 10, Y is our ticker, price is 20, and ticker has got X and multiple is 2, Y is 3. What do we want is, and similarly for price for X is 10.1, there are one more column, and 10.2. Okay, now let's call this second table as weightages. Okay, let's call this weightages, and then let's call it prices. Now what do we want to do is we want to compute the overall values, and overall value is summation of prices into multipliers. Okay, or you can say weight, right? Now in this case you should notice that what we are going to do is we are going to first join prices and weightages on ticker, right? First, this will be our joint data set, right? Now what will this joint data set do is basically it will make three columns. Okay, and then so for X it will be 10 and 2, for X it will be 10.1 and 2, for X it will be 10.2.2, and for Y it will be 20 and 3. Sounds good to you? And once we have generated this kind of data out of all of this, then we'll say group it. Okay, group my joined data by my ticker. All right, sounds good to you? And once that is done, then we do a say sum equals, uh, let's call it like this, and then we say for each joint, for each group, and then we say for each group, and then we generate group which will be the ticker one, and we say group. Okay. Okay. Summation of group dot price and group dot weight. Right? So is everybody agreeing with this? This is, the example. This is example. Okay. These are example. So this is what it looks like. So what we are trying to do is we have got two tables. One is prices, other is weightages, right? And f- then we are trying to basically compute this. We want to compute for each ticker summation of prices into weight. Okay, so 10 into 2, 10.1 into 2, 10.2 into 2, and then add all of these, and that's what we are trying to do. Okay, so ideally what will you do is first you join this, then you group this. Okay, then you generate this. Now if you allow me, if you think about this join phase will be going to sort this data on both the sides on ticker, and again when you group this data, it's again going to sort this data by ticker. So there are two times we are doing the sorting, right? We are doing the sorting twice, right? Agreeing with me? Whenever join happens, the key value pairs will be generated, and hence there will be a sorting involved. And then again when you join the data together, group the data together, again sorting will happen, and hence you will have this, right? Therefore, to avoid these two sorting steps, okay, to avoid these two sorting steps, you should generally say co-group this and that. You would say co-group co-group prices by ticker and weightages by ticker, and then you can iterate over. Okay, then result equals, you can iterate over CZ, and then you can generate, right? So that's the role of co-group. Whenever you need to do this kind of thing, joining and grouping coming together, you can take the advantage of co-group. Okay, all right. So we are left with only union, and we talk about pig. We'll talk about union maybe next session. All right then. Okay, so all of you have actually gone through most of the pig which is there. So I would request all of you to finish the quiz which is available in the in the LMS. So please finish the quiz on pig. Okay, do not do not delay it. Okay, because the quiz is fairly simple. All right, you can leave the subjective question aside. You can just look at the objective question as part of session 6. It would be there. All right, so please finish the quiz is fairly simple, and whatever we have learned today, you should be able to solve 95% of the questions. Okay, it will hardly take 5 minutes of your time to finish the whole quiz, but it will make you retain everything which we have discussed today. All right, so have a good day. Bye bye.